In this first dashboard, the butterfly chart shows the top categories that contribute to pollution in the entire United States, completely contrasting 1990 and 2019. We see that highway vehicles cause the most pollution across the country over these 2 decades. The emissions by state chart actually filters out the butterfly chart to show the exact breakdown per state per year at any time. For example, in Texas in 1996, miscellaneous is actually the top producer of pollution, and we can see how the numbers change to reflect the exact breakdown of Texas 96. In this next dashboard, we see another analysis of top pollutants, and we see that California, Texas, Alaska, and Oregon are top contributors to pollution, especially in the wildfire category. The donut charts take a specific view at our 3 states, California, Florida, and New York, to show the specific pollutant category breakdown in a more cohesive and visually effective way. The donut tooltip is connected to the overall top pollutants chart so that when hovering on a specific category, we also see the next 3 states that rank as high polluters in that said category, as well as filter out the chart to only see that category's trajectory. This dashboard is sort of a continuation of the top pollutants analysis, where we have a motion chart that gives just an overall view of each state. And the good thing about the motion chart is it's another way to view the different levels in each state in an interactive way, because the up and down motion helps us visualize which states rise, quite literally, in pollution values as opposed to others. The scatter plot compares which states were largest in terms of emissions for 1990 and 2019, and we can see that these dots that are far out shows that they were high in both 90 and 2019. As we can see, they were kind of their top players in both years, so it shows a sort of continuity over time of what should be our focus areas. In this next dashboard, we have the AQI analysis. A quick note, the higher the AQI, the worse the air quality index is. So that means that high numbers are places where we should be focusing on. The good versus hazardous days butterfly chart just shows for each city how many good and how many hazardous days they have. What's nice about the packed bubbles chart is that it actually filters out this chart so we can specifically see what cities with high unhealthy days and high AQI have in comparison to their good and hazardous days. And the data often correlates. For instance, in one of these light small colors, meaning low AQI and low unhealthy days, we see that there were no hazardous days and over 100 good days. This allows us to confirm and validate our data because we see these correlations between the good, the unhealthy, the max AQI, etc. The map shows days with AQI to unhealthy days, with color relating to AQI and size to unhealthy days. California and New Mexico are the worst performers from this analysis. The histogram bin indicates how many data points fall into each category. Each category strays 50 AQI points from the mean AQI value. We see that most cities fall into the median bin at a whopping 220 cities. This histogram is similar to the first, but this time each bar is broken down into the AQIs of specific cities, the ones with the 25 worst. Their individual max AQIs are listed in the tooltip. This breakdown shows us what cities are in each bin to show us where the 25 most at-risk AQI regions fall in comparison to the mean range. So when we see in the preliminary histogram that 2 locations deviate far from the average, with a location breakdown, we know that these 2 are California and New Mexico. In the US net emissions analysis, we have a bar chart with a calculated field that shows the difference between 1990 and 2019 emissions. The net emissions per state by pollutant category chart shows the net emissions as broken down into their respective pollutant categories. The donut chart sums these net emissions by category for the entire United States, and when hovered on, filters the bar chart to show only the selected category, as well as shows the 4 states with the highest pollutant values in that category. For the most part, California and Texas appear the most in this top 4 highlight. The ozone analysis is a rather simple dashboard featuring 4 maps across the years, which shows the ozone levels in each state with a darker shade meaning more pollution. The change isn't very noticeable between 1990 and 2021, suggesting our US pollution conditions have somewhat stagnated in the last decade or 2 due to a lack of substantial and long-term policy initiatives to combat climate change. The tree map highlights the top 25 cities with the worst ozone conditions. In the air quality analysis, we have the analysis of AQI influencers and the analysis of unhealthy day influencers. These two bar charts operate almost in the exact same way in that they take one category, either air quality index or unhealthy days, and compare it with the different pollutant gases in the air to determine which of these gases influences these factors the most. The color scale is based on the max AQI, and so is the size, so a thicker line versus a thinner line. What we see clearly is that in both unhealthy days and AQI, the top reasonings why you would have a bad AQI or a high count of unhealthy days is ozone and PM10. So that tells us which gases we should specifically be targeting in our propositions. The scatter plot is really just a visual aid because the colors really help us to see how much of the United States is experiencing more unhealthy versus more good days. And we see it's kind of a 50-50 split. What's really good about this is identifying the outliers because we see that they're usually from California for the most part, which tells us which states are experiencing the most unhealthy days. The waterfall chart takes a filtered view of the top 25 cities with the most unhealthy days to see where they rank amongst each other. The Phoenix, Mesa, Scottsdale region of Arizona actually has the most unhealthy days in all the categories: unhealthy, unhealthy for sensitive, and very unhealthy. In the US air quality correlations, we look at the entirety of the United States. It shows the correlation between days ozone and good days with all types of unhealthy days. All of the p-values showed successful results. For the lower the p-value, the greater the statistical significance of the observed difference. Low p-values for our correlation charts means the relationship between poor ozone conditions and unhealthy days did not occur by chance and in fact has significance. As you can see, these are all really small numbers. On the other hand, our correlations between different gases in the US were mostly above 0.05. What this tells us is that gases are independent of each other and have the presence of one generally does not predicate the presence of another. Locations will usually have a lot of one and not much of the other, or not much of either, as seen by the large cluster of data points near the origin. In the state analysis, this dashboard focuses on our three chosen states, California, New York, and Florida. This stacked chart shows how much of each gas each state has. By color coding the state, this chart serves as an easy visual overview of what states have more or less of each gas. Honestly, I was surprised to find that New York had the most of each harmful gas, for I was expecting it to be California, given that California is consistently the state with the most emissions. That being said, California ranked highly in the PM10 category, whereas New York ranked highest in the CO, NO2, and SO2 categories. As we saw earlier, PM10 is one of the strongest factors that causes high max AQIs, whereas the other three aforementioned gases have little to no effect. So evidently, the data is not that far off after all. The 90th percentile analysis is a histogram that shows where the cities in these three states fall in relation to the 90th percentile. All of New York falls in the 90th percentile, but unsurprisingly, California is very far off. The unhealthy days analysis is a multi-scatter plot that shows ozone good and unhealthy day correlations, similar to the US chart in the previous dashboard, except this time only for our chosen three states. Again, most of our p-values were above 0.05, indicating that ozone does not have high correlation in these. In the continued state analysis, a waterfall chart filtered to only show California, Florida, and New York shows overall emissions in 1990 and 2019. California's values surpass Florida and New York significantly, with New York having the least emissions but the largest change over time. The box and whisker plot shows the net emissions per category. The values are plotted to show the breakdown of emissions, and the color scale relates to net emissions, which shows which states had the greatest change over time. California had the most change, as it declines the most, but it's still the top pollutant because its starting point was so much higher. In conclusion, my analysis helped me to target the states in the US which need the most attention in terms of eliminating pollution, as well as understand what gases cause the most problems with pollution and air quality, in this case, ozone and PM10. I was also able to compare geographical regions to determine that the west coast of the US experienced worse air pollution than the east coast. This knowledge will help our team to direct our efforts at the west coast more than the east, at least when the initiative starts and is small or low on funding. In this case, we should focus on California, Texas, New Mexico, and Alaska, in addition to the rest of the western half of the United States, at least at first, and especially devise solutions that combat ozone and PM10 levels, as these are the top contributors to poor AQI and unhealthy days.
We will be taking a closer look at three states, California, Florida, and New York. We have incorporated pollution data, electric vehicle registration data, efficient energy employment data, along with other useful metrics. It is also important to know that we filtered out wildfires and prescribed fire data because these are not common among all states. Furthermore, wildfires are natural phenomena. We will start off by analyzing the pollution data of all three states. Firstly, we have California. The total emission level has decreased almost fivefold since 1990. The figure has dropped from 15,631 to just under 3,500. In addition, we see that highway vehicle emissions accounted for over half of all emissions in 1990. In 2019, however, this figure has reduced to just under 27%. On the other hand, however, over the same period, off-highway pollution has been steadily increasing. Next, we have Florida. We see a similar story as with California. Total emissions has reduced significantly. The figure reduced from 9,538 in 1990 to just under 4,000 in 2019. In 1990, highway vehicle emissions accounted for almost 50% of all emissions. In 2019, this figure has dropped to just under 40%, while off-highway emissions has seen an uptick. Lastly, we see a repeat story with New York. Total emissions has decreased fourfold from 8,515 to just under 2,200. Highway vehicle emissions accounted for over 50% of total emissions in 1990. This figure, as of 2019, has reduced to just above 32%. We also see where off-highway pollution has been steadily increasing its share of the total emissions. Here, we compare the total emissions of all states. We see that Florida has the most emissions, followed by California and New York, respectively. We also see that the top three emission generators for all three states are highway vehicle emissions, off-highway emissions, and miscellaneous emissions. Next, we visualized precipitous decline in emissions of all three states. This is truly remarkable. Lastly, we visualize the decrease and/or increase of each emission generator. We see that highway vehicle emissions, off-highway emissions saw the largest decreases, while miscellaneous saw an overall increase in 2 of the 3 states. Here, we compare the number of electric vehicle registrations to highway vehicle emissions. We see that the uptrend in electric vehicle registrations has contributed to a gradual decline in highway vehicle emissions. The forecast feature was also used to further elucidate this finding. Next, we see that all states have been aggressively hiring persons in the clean energy generation sector. The motion chart also shows that there has been a general uptrend in employment in the energy generation sector. Here, we did a forecast and trend analysis on the highway vehicle emissions. We see that the emissions level is forecast to continue its downtrend. Here, we have a correlation analysis between emissions level in 1990 and 2019. We saw that there are many outliers, whereas in the comparison between 2010 and 2019, the data is more linearly defined. You might also realize that there are 2 clusters in this analysis. I used a cluster analysis to identify the emissions generators that are deemed to be under control and the ones that still need some work. Unsurprisingly, we see that highway vehicle emissions, off-highway emissions, and miscellaneous emissions are the generators that still need to be reduced.
Hello. For part 3 of our analysis, which is country compare, we've decided to focus on France and the United Kingdom as 2 other countries to compare to the United States to see how the United States is doing in their overall pollution emissions. So to start off on this initial dashboard, we have the overall country analysis. So we look at carbon emissions, NO2 emissions, PM2.5 emissions, and sulfur dioxide emissions. And we look at them for both France and Great Britain in this butterfly chart. So some interesting points that we see here are that the NO2 and the SO2 rates are higher in Great Britain than they are in France, not by much, but it's still a noticeable difference. We also notice that the CO and the PM2.5 are higher in France than they are in Great Britain. In France, for CO, we have 95.62, while in Britain, we have 67.3. Similarly, for PM2.5, in France, we have 13.7, and in Great Britain, we have 12.20. So as you can see, with things like the PM2.5 and the NO2, we don't see that great of a difference. And with CO and SO2, we do see really big differences between France and Great Britain, but it varies depending on the chemical. So from this overall country analysis, we can't tell off of first sight which country is doing better, France or Great Britain. This just gives us some initial things to look at. Initially, we can also see that carbon is one of the really, really big emissions in both France and Great Britain. So that's going to be something very interesting to look at and to analyze when we're also comparing it with the United States. So now we've kind of tried to look at which one is worse, France or the UK. And my initial hypothesis is that France is going to be the worst country. However, as we look through each individual emission, I'm sure that the conclusion that we come to for that hypothesis will change. So beginning with carbon oxide comparison, initially, when we look at this box and whisker chart, we see that it appears that France is greater than Great Britain when we're looking at carbon. Not only that, but when we look at the highest value for France, we see that it's 191.3, and then when we look at the highest value for Great Britain, we see that it's 143.7. So we know that France was significantly greater, especially because of this big gap right here that we see, that France was significantly greater than the United Kingdom in carbon emissions. And as we look here, we also see that Great Britain wasn't as bad as France, and not only that, but they are a little bit better than France. Something interesting to note is how big the gap was initially and how small the gap was now. So it kind of shows us that France has done a lot to improve their emissions, and Great Britain is still consistently doing good. However, Great Britain did have less work to do than France did, so that's also something to keep in mind. Another thing is over here we can see how in France we get some darker colors showing us that we have darker values. However, in Great Britain, the darker values kind of start over here while they start over here. So France is in 1996 where Great Britain was at 90. So there's around a 6-year difference. However, as we come to 2019, we kind of see that starting to even out as France is starting to catch up to how Great Britain is doing, even though there is still a gap. Another thing to notice here is to find out exactly how much France and the United Kingdom have done is that we can take a look at the upper and lower whiskers of this box and whisker plot. And for France, we see that the difference between 191.3 and 36.4 is 154.9. So that's kind of how much they decreased in their emissions on average. And when we look at it for the United Kingdom, we see that 143.7 minus 23.4 is 120.3. So that's kind of how much they've decreased their emissions. So once again, while France did start out higher and is still a bit higher than the United Kingdom, they've had a lot more bigger progress in their emissions than the United Kingdom has by around 30 points. So moving on to their nitrogen oxide emissions, we believe, according to the trend line, will happen in the next few years. And according to this forecast, we can see that Great Britain is forecasted to have a decrease in emissions compared to France, and that eventually they will reach the 0 point of NO emissions, or not the 0 point, but they will reach that lesser emission status faster than France will. And we can kind of see as we look here what some of the higher values are. Over here we have 55.73. And over here, we have 36.83. So it shows that interesting difference. Now, looking towards the PM 2.5, we see that for both Great Britain and France, they follow a very, very similar path. And they're mostly decreasing. However, they're both in these very, very high value fields, even though we want them to be down here. But throughout this kind of like trend, we see how they're decreasing. But for the most part, they're kind of taking that overall same trend. We can see over here, it was going down. Over here, we have some discrepancies. It's going up and down, and then over here it has been staying pretty constant for PM 2.5. And we also see here that France is doing a little bit worse than Great Britain is, right? They have a little bit more higher values than Great Britain is, but not by that much. But over here in 2014, we see that France was able to decrease and reach almost the same value as Great Britain. And that decrease was by around 2 to 3 points. So what exactly happened in 2014 that made France go through that? We find out that in March of 2014, France implemented a car ban in Paris since the pollution rates were getting higher and higher. And this car ban lowered the PM 2.5 rates in France, which is what we believe attributed to this decrease. So that's also something very interesting to consider when we're looking to our overall analysis and whether or not our initial hypothesis was correct. Finally, as we looked to the SO emissions, we see that obviously France is a lot lower here, right? France is valuing at 21.48 in the year of 1992, while Great Britain is valuing at 59.64. And because of like the area filled out in this chart, you can kind of see how Great Britain is obviously a bit larger than the United Kingdom. Now, when we look at the second chart and we only click on Great Britain, we see how the legend goes from 130 to 0, showing us that there is a lot of emissions of SO in Great Britain. But when we switch it to France, we see that the legend goes from 0 to 50, showing us that that's not the same in France. So what did we just kind of analyze after looking individually at these 4 different emission rates? We can definitely conclude that carbon emissions are the worst overall. This was definitely supported by our hypothesis, and that is 100% proven. We can also see that in general, France does do a little bit better than the UK, which does support our initial hypothesis. And in France and the United Kingdom both, we saw that carbon dioxide was by far the biggest pollutant. So now it's interesting to think about what causes these emissions. So upon further research, we found that in the United Kingdom, the 2 main contributors to pollution are domestic wood burning and road transport. In France, their biggest pollutant is primarily transportation. So now, all of this plays a crucial role in looking at the USA, because we want to see how the US compares to other nations that are comparable to them, like France and the United Kingdom, and whether the US just needs to change their policy to something that other nations like France and the United Kingdom are doing, or whether the United States is doing really well already. So for our comparison of France and the United Kingdom versus the United States, we'll now take a look at some interesting things that are happening with pollution in the United States. So starting off with this dashboard, the top pollutant categories in the United States, we can automatically see from this graph that the number 1 pollutant in the United States is highway vehicles, right? This is very obvious to us because not only is this circle bigger than the rest of them, but their emissions are in the 100,000s, while other emissions are in 40 to 50,000. So when we move on to another dashboard, the United States air quality correlations were once again supported with this, because what pollutant comes out of highway vehicles? It's often carbon dioxide and PM 2.5. Those are the biggest byproducts of highway vehicles. So in the last dashboard, we saw that highway vehicles were one of the largest pollutants in the United States. And now over here in this graph, when we look at the correlations and highlight any of the circles here, we see that PM10 and PM 2.5 are what we see the most often when we're looking at the frequency of the dates. So we obviously see that PM 2.5 is the largest pollutant in the United States, which is different from what we saw in France and the United Kingdom. Finally, when we look at the state analysis board, and we look at these 3 different states right over here, California, New York, and Florida, once again, we see that both PM 2.5 and PM 10, stand out as chemicals that are high in the number of days they've been seen in all 3 states. And these are some states that stood out to us because we thought that they would be the most comparable in terms of land space, in terms of pollution, in terms of large populations, and in terms of interesting climates. So what we see here is that PM 2.5 stands out from all of the other chemicals, which is different from what we saw in Great Britain and France. From what we've seen here, some of the biggest contributors overall in the United States is highway pollutants and wildfires, of which carbon dioxide and PM 2.5 are 2 of the biggest byproducts. So we've seen that kind of throughout the 3 different dashboards that we've looked at. So what we can see here is that France and the United Kingdom have different strengths than the US. So in our analysis, we kind of advise that the United States, who is generally doing a good job, does implement a few more stricter measures to increase their air quality because they have different strengths than the France and the United Kingdom have. So one example of this could be implementing the car ban that France did, like we talked about a few minutes ago. And now in part 5 of our project, we will discuss more measures that our group believes that the United States should take through our analysis. Thank you.
For my part of the project, I'm going to be taking the information that Naila just discussed and analyzing it a little bit deeper into how each country is trying to decrease the amount of pollution in its air. I'm going to mainly talk about the growth of wind and solar companies along with the EV industry and how that is being impacted as well. So as you just learned from Naila's explanation of the abundance of pollution in France and the UK, both countries seem to be on a steady decline in eliminating pollution in their air. And as you will see, this makes sense because throughout the last couple of decades, both countries have made strong efforts to create more wind and solar power sources and other fields to create renewable energy. The rapid growth in wind and power solar have lowered emissions and will continue to decline in the future. So right here in this butterfly chart, the onshore wind capacity of both France and the UK is compared with France on the left in blue and the UK on the right in pink. The continuous growth in pollution in the air, as we saw in Naila's charts, likely caused an increase in wind capacity for both countries. From 1990 to 2005, the UK had more growth in wind capacity. However, around 2006, both countries started to grow at around the same rate. This increase in wind capacity is causing an increase in wind turbine fields, creating more employment opportunities for both countries. The job growth in both of these countries has been on a continuous rise in hopes of eliminating pollution and creating a cleaner environment. The decrease from 2019 to 2020 is likely due to the COVID-19 pandemic and less people traveling, causing less pollution to be in the air. And below is another butterfly chart showing the solar capacity growth in both France and UK again, with France on the left and UK on the right. This chart looks much different from the one above it because from 2004 to 2014, France showed a significant increase while the UK showed relatively nothing. The high demand in France for the solar industry has resulted in many jobs for citizens and is working to help the environment. In the UK, the solar industry didn't begin to boom until 2015, and this is because UK was given a feed-in tariff subsidies to grow their renewable energy sources, so they got more money from the government to make more renewable energy. This is why there was a rapid increase, as you can see, from 2015 to 2020. And just like the previous chart, you can see that from 2019 to 2020, there was a decrease likely due to the pandemic. On this next page, I actually created a motion chart for both the solar industry and the wind industry in France and the UK. Let me just reset it. In this top one, France is represented by the blue square and the UK is represented by a pink circle. As you can see, both industries, I will play it right now. So you see they both start pretty low and then they both increase at pretty much the same rate. And this is for the wind sources. And right here in the solar capacity, you can see that France is again the blue square and UK is a green circle. And here you can see how long it took for the solar industry to grow in the UK compared to France. In these next two pages, I will discuss how the growth of wind capacity in France and the UK and the solar industries will be in the future using the forecast feature. As you can see, it is increasing at a steady rate, and it will continue to grow in the future as well. So this is for France, and this is the UK, pretty much with the same pattern. And then on this page, you can see the same thing, but for solar companies, both increasing at a pretty steady rate. So on this page, you can see how the EV industry in the UK has been affected and how the number of jobs in the industry have been on an incline. Each individual car here shows the number of jobs in each year from 2013 to 2020. And over here is a donut chart with the same information. The demand for electrical cars has been high in an effort to reduce the amount of greenhouse gases in the air. Although electrical vehicles still release emissions, they ultimately do less harm to the environment than normal gasoline vehicles. And the greater adoption of EV, like the electrical car industry, ultimately creates rising demand for existing jobs and will produce opportunities for new jobs in the future. Although this increase in electrical vehicles could create job losses in the oil and conventional car industries, there will be net job growth. And on this last page, I thought it would be interesting to compare hydro capacity in both both the UK and France. Here is the UK, and as you can see, they've been using hydro renewable energy for a very long time and much longer than France has, and at more of capacity. So the UK is pretty much just growing, and France is on an incline as well. And then below, I thought it would be interesting to compare both offshore and onshore wind capacity in the UK, and they are growing at pretty much the same rate as well.